Parabolas, 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 parabolas. It's all about parabolas. It's all about parabolas. It's all about parabolas, parabolas, parabolas. Parabolas are amazing things. It's what we get when we throw anything on this planet upwards and with some forward force. So I'm, well, forward, lateral force, horizontal. So because we throw it up and an element of horizontal. So I'm throwing this sideways and upwards, and you get this special curve. It's called a parabola, and I've got my fish parabola here. It's got a more or less parabola. It's not a very precise parabola, going up and down. And I made my fish because I like my fish, and anything that you throw in the air. So have a go. Throw whatever you want in the air. Even yourself, if you do a long jump or something, you're running along, boing, you jump up. Well, if you're going forwards, and not with the high jump, because you've got a stick and that changes your path. But once you let go of the stick, you are following a parabolic path because the gravity is what pulls you down. So it's all about parabolas. And how do we describe parabolas? Well, first of all, if you're still in primary, just think about cannonballs. Let me just share something with you quickly. Let me see if I can find a picture to share with you very super uber quickly. So these are the sort of things that you will find in, oh, that's not quite parabolas. That's something we were doing for the early years. So I'll share an activity with you, an activity set, which covers all the way from 4-year-olds all the way to 18-year-olds. So that's the bit for 4-year-olds. Here's your bit. If you're 7 to 11 years old, that's all you need to know is look at the path of the ball. You've got the cannonball, the golf ball, the cricket ball, the football, the basketball, what other kind of balls are you playing with? I've got my, whoops, don't know what happened there. I've got my juggling ball here, which I dropped on the floor and broke everything, not quite. I've got my juggling ball, and it's just every time you throw it up, if you give it some forward motion, always makes a parabola. Ski jumps, boing, boing. The ski jump, as soon as they're free of the ski slope, boing, they're making a parabola. Skate park, people on skateboards, if you've ever done the jumpy things where they go up a ramp and then they go forwards rather than back down again, as long as you're in the air, it depends whether you've got any forward motion or not. But if you go over the top and you travel along, the people that do the crazy jumping across buildings, every time they jump from one building to another, it's a parabola. Every time you jump, if you've got forward motion, it's a parabola. And we've got some equations to go with it. So let's have a look now at the next level. And we're going to look at, stop sharing this one. Oh, no, I'm not. Yes, I am. I'm going to stop sharing this one and I'm going to show you the other one, which is right here in share screen. Here we go, on the visualizer. So how do we describe parabolas? Right, so what is it? Why are we? Yes, here we go. Well, what we've got here is a few equations. We've got equations which are parabolic. They describe parabolas. And the first, so what we're doing here, what this activity is going to help you do is, in a fun way as possible, help you really understand these quadratic equations. Okay, so what you're going to do with this, first of all, you're going to match all the equations here. And you have an activity, there's a whole sheet, I've cut these out of here, but there's sheets that you can download. It's a whole activity pack. You don't have to print them out. If you can't, you can just draw them, you can write them out, but you can download the activity and get all the information that you need. And this activity pack takes you all the way from age 4, as I was saying, all the way up to age 18. So it's what they call low threshold, high ceilings. It covers early years, it covers special educational needs, inclusion, and it takes you where you are and takes you up a little to another level. So if you just started to learn quadratic equations and maybe you haven't completely understood them, this is a good way to get familiar with them. So the first job is to see if you can match the equations. And if you're not quite sure which curve each one of these matches, well, you can go back a step. And you can say, right, let's have a look, and that activity is further on in the pack as well. This is just the front page that gives you a kind of a one activity, and there's lots of other activities. You can say, take a step back and say, right, if x is 0, so at the point when you're on the 0 point of the x-axis, which is where it intersects the y-axis, then what is y when x is 0? In this case, if x is 0, then all that's left in that bracket is 0 minus 8, which is minus 8. And you've got 0 plus 2, which is plus 2. So it's minus 8 times plus 2, which is minus 16. So which of these graphs has y being where x is 0? So let me see, how many have we got? We've got, well, at x is 0, that's positive, that's positive, that's positive. Oh, that one's negative. Oh, that one's negative. That's positive, and that is negative. So we know it's going to be one of that one, or that one. Then you can go from there. You can just simply plot the coordinates. So you can just put in different values of x, keep them small, go 1, 2, 3, 4, or go negative if you want, but you can just stay positive, just stay positive, just keep positive, you'll be grand. And then you can plot the curve, and then you can see which one of those, or you can also put in, yeah, just plot the curve. And then you can identify which one's which. So do it slowly, take your own time to do it. And then you'll be able to identify which one of these equations, which ones are the same, because they're written in different ways, but they might be the same equation. So just written in a different way. So they're interpreting the same curve. They match out to the same curve. They are the same curve. So it's up to you to find out which of these match which of these curves, and then you can put it on. Well, we know that one's, which one did we have there? We said that one was, it wasn't that one, it must have been this one. This one, we said it could be one of these. Let's pretend it's that one, it might be. And then you just put the ones that match the different curves on the different curves, and you're done. Now, other activities on there. I'm going to change the screen again. There are other activities on there, and I've got to find a way, stop share, there we go, hello. Right, so this is going to take you literally, as I say, from just looking at curves, doing nothing but looking at curves, to looking at parabolas, and then you're taking it on to doing more exercises. And there are answers, by the way, but don't look at them until you've had a go, and then you can check what you've done. And then there's basically more things to help you. And what is it? What's the point of doing this? So you're identifying, well, it's helping you learn quadratic equations. It's helping you learn it in a more, it isn't just learning it and practicing it. It's helping you, the activities, if you follow through the activities on here, it's thinking mathematically, reason logically, give explanations. Hopefully you've got someone they can give explanations to. You can teach someone that's with you how to do it. Maybe not someone that's younger than you, or it depends if they're ready to learn quadratic equations, but help teach someone that's older than you, perhaps. It helps you to think flexibly, be creative, innovative, apply knowledge and skills. And all these things are things that will be useful to you throughout your life. This is why maths is so important. And it helps you develop skills of visualizing. Well, anytime you have to make a decision, anytime you want to do something new, you want to create a project, you have to visualize. And the more you practice the skill of visualization, the better you will be at creating projects, whether it's art or whether it's you want to maybe do an enterprise, if you think you might want to be an entrepreneur, you have to visualize. Or even if you want to be a doctor or a nurse, or you want to be a lawyer, you still have to visualize. Like a lawyer, if they want to win a case, they have to visualize the best way to win the case. It's not just applying the memory that they've got, It's also using creative imagination to actually solve a problem, which is how to win the case against another lawyer who might be just as good as them. And they're doing their creative bit to get them to lose the case, the other one to lose the case. So win their side of the case. And you can win arguments as well. If you're good at visualizing, it helps you win arguments as well. Shh, don't tell anyone I said that. And also it helps you get what's in your head into real life, creating real things. Did you know that mathematicians love problems that they can't solve or that they don't know how to solve? Did you know that? Now, do you think that someone that's gone through all their life doing maths and they're a professional mathematician, they get paid for doing mathematics, do you think that them not knowing how to solve a problem, do you think that they are clever or not clever? You bet you they're clever. And the fact that they love finding a problem that they don't know how to solve means that what they are experts in is in how their attitude towards problems. So if you want to be super clever, the best way you can be super clever is whenever you find a problem that you don't know the answer to, you think, oh, I don't know how to do that, I can't do that. Think, oh, wait. The cleverest people don't see something and think, I don't know how to do that. You know what they think? They think, how do I do that? And you know what that gives you? It gives you a sentence, instead of like, oh my goodness, I don't know how to do that, I better not do it because I might get it wrong. And you feel all panicky and, you know what it gives you? It gives you a sense of, it gives a sense of peace and kind of harmony. You think, oh, that's cool. And then you can get excited and go, oh, I'm going to learn how to do this. And when I've learned how to do it, it's going to be so exciting that I'm going to actually succeed in doing it. And you know what? When you do succeed in doing something that you didn't know how to do before, it feels so good. It's like, wow. And you go like this big, aha, ooh, you get really excited. It's like, there's not really that much that excites me more. Okay, so if that was more fear, if I'm going on a roller coaster, that's more fear. There are things that excite me, going on holiday and things. But that feeling when you solve a problem that you've been struggling to solve, it's like the best. And that is worth going through the whole journey. And there are problems that mathematicians still haven't solved. And you know what? If you get really good at solving mathematical problems, there are prizes. There are some problems in this world that there are prizes to solve. £1 million, which is like $1.5 million. And it's like, oh goodness knows, like 10 million rand, something like that, 7 million rand, lots of rand. What other currencies do I know? Oh, krona, Danish krona, that's 10 million krona. Is it? I've forgotten, I've lost track of the krona now. I think it is about 10 million krona. And it's a lot of money. And if you become a mathematician, and then you could win £1 million if you solve the problems. Ha ha. So thank you for joining us. Let me just see if anybody's made any comments, any questions on YouTube, if I can find YouTube. I've lost YouTube. Wait a minute. Was the screen shared at that point? I keep having the screen shared when I'm talking to the camera, and then I'm this itty bitty person, but I haven't done it this time. Let me just see if anybody's put any comments. Here we go, found it. No comments that I can see at this point, which is grand. I will, I'm going to put the link to the activity, so you can go and look at the activity, and depending where you are. And the thing is, once you've got the activity, depending what age you are, you can just look at the parabolas and making a parabola. Oh, I didn't show you how to, you can, if you use slow mode on a phone, going to erase this, which is how I made this in the first place. Let me take my microphone and bring it round so you can hear me. Whoopsie, microphone's on the floor. go. Now, slow-mo. Draw a grid. Whoops, that's not that's permanent. Draw a grid on a big sheet of paper. Get somebody to hold it up or paste it to the wall or something. Draw a grid. Doing, 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 doing. Right, ready? Now get your slow-mo camera and throw the ball. Get someone to film it. You throw the ball or other way around. And get as close as you can to the slow-mo. And now even use your memory to plot that as best you can. Probably do it a different color. And even you could plot it a few times and see if you throw it higher or lower. What if you only throw it very low? It kind of went like that. And you can plot your parabolas and see how many different parabolas you can make. We're making a parabola, parabola, parabola. We're making a parabola, parabola, parabola. And we express it in maths, in the maths classroom, using a quadratic equation. Thank you very much for joining us, and I will see you tomorrow with more maths, with more bubbly maths and AIMSEC. It's all thanks to AIMSEC, all these activities, and the Aiming High website, and the link is down below. And I'll also put a link to the Maths Toys YouTube channel. So please do, if you're enjoying these, please do subscribe, give us a like, and then ding the notification bell so that you know every time we go live or whenever we upload a new video. And I will see you next time. Caroline from Bubbly Maths, signing.